All right, number 17. Find the indefinite integral. So we will have this plus c here at the end of some sort. And here we go. Now, I'm not going to guide you per se. I want to see what your approach is. Should you use U-substitution, yes or no?
No. Yes.
Okay, those of you who said no, why do you say no?
Which one? I just don't know which one would be the biggest parenthetic piece.
Okay. And those of you who said yes, why did you say yes?
Because tan is the inverse of secant square, so you can cancel out secant square.
Okay, so tangent is the inverse or the antiderivative?
Oh, antiderivative.
Okay, so tangent is the antiderivative.
So
He sees a relationship between secant squared and tangent. And he has this memorized that's telling him we should look at those two pieces, possibly with U-substitution. But there's something else for participation points that is in this problem that would tell you you should probably use U-substitution. What is it? It's something simple but huge and important. It's multiplication. Because we don't have a reverse product rule. We have a reverse power rule. We have a reverse constant multiple rule, if you will, but we don't have a reverse power rule. There's no such thing as a power rule that's being reversed. Oh, sorry. Product rule is what I meant to say. A reverse product rule. Guys, what's the product rule going forward? It's the first times the derivative of the second plus the second times the derivative of the first. There's no backward process to that. The way, and it's not quotient rule. No.
I said minus instead of plus.
Oh, no worries. So the multiplication right there should tell you, along with what Cooper was saying here, it's going to be U-substitution. So now, it's all about the rewrite to find the biggest parenthetic piece, okay? So this probably most likely would be written like this on your test, okay? You'll have tangent of 5x square rooted, and it'll look something like that if it was given to you. The rewrite, and you know you have to rewrite this for your calculator for sure, otherwise it doesn't interpret this. It'll only interpret this notation for secant squared. And yes, there's a 5. And then you have the rest. So notice the rewrite that I'm putting, okay? So tangent of 5x to the 1/2. And yes, this is 5x. Let me write clearer. Okay? Now, how many parenthetic pieces do you see? I see 4 different parenthetic pieces. I see each of the 5x's, and then I see this parenthetic piece or this parenthetic piece. Remember, my suggestion to you was to go for the biggest one. So what do you think we should assign? I already told you. What do you think we should assign as U? The tangent of 5x. We're going to basically gobble up all this piece of the problem so that all we have to figure out when we do the U-substitution is all of that. And you'll see what I'm talking about here in just a bit, okay? So it's because it's the biggest parenthetic piece that there is, okay? And guys, you have to gain a lot of experience with problems and practicing in order to see these faster and clearer, okay?
So it's not by the power, you can't evaluate it by the power raised to 2.
No, not per se, not that. You want to go more so for the biggest parenthetic piece.
So let's say that I chose like the secant 5x as my u. Would that still give me the right?
Okay, let's do that. He's saying, what if we chose secant of 5x? This is going to segue with what Cooper was saying as far as what he identified and saw. Now, if this is u, and we know we're going to take the differential, what is the derivative of secant of 5x? We can't forget derivatives, guys. We can't. It's secant tangent, right? It's secant tangent of the stuff, right? What am I missing? missing still? Times the derivative of the cream. But I'm still missing something because it's implicit. dx. Now, do you see this in the problem? He chose to use this. That means everything else should come from that. That's too much. That's way too much. There's a lot of stuff that was not there in my original problem. So, and are you going to experience those mistakes? Yeah. And it's good too because you'll know next time what maybe not to do for you for your U substitution. But looking at this, we're going to say that U is equal to tangent of 5x. Now, here we go. What's the derivative of the left? du. What's the derivative of the right? 5 secant squared 5x dx. Now look, I assigned this as my u. So far my equation looks like this. Are you with me? I still have to gobble up all of the remaining scraps, if you will, of my original integrand. Well, get this. Secant squared 5x is actually going to come right here, and there's your dx that matches the pieces that I still need to use. The only one that is not in my original integrand that just popped up out of nowhere is what number? 5. And again, if you divide both sides by 5, you're going to replace everywhere where you saw this originally with 1/5 du. It's like you're coding it, if you will. Okay? So everywhere where this used to be is now going to be 1/5 du in the same exact spot per se. Okay? Just like this tangent is coded here, all the rest of this implicit differentiation piece is now coded there. But for the sake of notation, I'm going to constant multiple rule and make this a lot easier to look at. And I have this. My goal with U substitution is to create something that I can do reverse power rule just like that. Are we good? So what does u to the 1/2 become? U to the 3/2 times what? 2/3? What am I missing?
1.
I got to multiply by my constant multiple. And I'm also missing something else. Plus c. Now, this can be written as 2u to the 3/2 over 15 plus c, but it's still incorrect. I have to plug in my original u assignment that I came up with back so that I have it in terms of x. Cool?
How did you get the 1/5 over there?
Because when I did the derivative here, this 5 was implicitly multiplied. Remember, you got to multiply by that derivative of the cream. And I needed it to have 1/5 du is equal to the stuff that I found in my original integrand that it was going to replace. Substitution, substitution all day. The way we started with our example of the system of equations one. Is there one roadmap to get these answers? No. Okay, your experience will build your familiarity, but I can't give you a acronym like DREADS that it will be able to solve every single one the same way. It's just not like that. Any other questions on this question before I stop the video?
Can you rewrite secant squared 5x as tangent squared 5x plus 1 and then
You can, and it's equivalent, yeah.
Wouldn't that go much faster than this?
It depends on you. Again, everyone's going to have a different approach. All right.